Sending. Det skal du ikke begynne nå. Sending begynt. Ok, så. Liksom her i gang, så vi går inn. Dette i teorien der det skal begynne. Om 4 minutter, ny tur, sant? Jeg tror det denne. Det det du Ja. Det begynt nå. Ok, kan du gjøre noe tjeneste? Kan du sende den linken her på Facebook nå? Du går ut til resepsjonen, høre på lyden, og komme tilbake igjen. Videre?
That's something what we're doing now. I actually wanted to talk about content management platform in this talk about interest of time. I was told that I need to construct more talk, and so I'm just going to limit myself to the local. Kind of breakfast seminar, talk about the different problems that you solve.
Just do one bit, then just come we're both done.
So I'm just going to use two scenarios, right to access and right to initiate, and then that's kind of representation.
More specific and a bit more like I need to work on my presentation.
Det bra?
Still having clients there. Yeah. We have people come as well.
Ja, det nettopp det. Så, vent litt, jeg begynner å skrive. Den ser ut her. Ja. Den lyden her med. Vent da.
Jo, det går relativt bra. Det jo folk kommet kortere enn jeg hadde trodd. Ja, jeg snakket akkurat med Gartner nå. Og de hadde en idé for et halvt år siden, så tror jeg 60% på den ferdig. Nå tror vi
Går det feil vei?
Webkamera. Kan du gå og høre nå også? Nå det ikke den her.
If you have a break. Jeg tror det det som skal være tillegg. Selskap som heter IBC, så du lager noe som heter Har du egentlig billetter mot deg? Bortsett fra Gjøvik, for det var litt sånn ærlig da, folk fra Gjøvik som var med.
Det litt mer sånn.
Dette har jeg ikke hørt om. Det høres utfordrende ut. Jeg setter i gang.
Ja, det bra. Nei, så Gartner sa også at fokuset på, altså hvis det sånn fokus, så var det 60% Europa,
Skal vi ta noe kaffe for det?
Jeg tror jeg tar det seriøst. Da tror jeg vil være mer vant til personer også. Når vi snakker om amerikaner, så det når vi sier at man må tenke helt klart hva som kvaliteten. Så det ikke blir det. Webinaret senere i dag og internasjonale akademier, så det hovedsakelig det sier jo litt av vi vel sikkert der hvor folk i Norge var for stater skjer. Det de fleste penger kommer fra.
Da kommer til å snikke.
Interessant. Nei, da. Så det er morsomt å se det.
Jeg er rå på snikking, bare vent.
Har du sett for det?
Det er smart. Så en snublet og sånn, da blir det veldig dyrt.
Hva er det? Blir det streamet live? Kunne sitte og sette på nettet selv. Den blir lagt ut på noe?
Ja, jeg legger det.
So how's the MD list? Is it architect?
Det her er finere. Så litt rett ut. Hva tid er det?
Litt mer litt så
I would rather suggest really catch the deadline.
We will start in 5 minutes, okay? Just wait some more people.
I'm Graham. Nice to meet you.
Vil du sende noen slides?
Får vi filmet det nå, er det sånn?
Short time, new talk, let's see what happens.
I don't know if they're going to stream it, so
I can send you
I think they were going to try, but I'm not sure they're going to manage.
yeah.
Okay, so nice.
And I sent it on our social media. I'm sending it.
Good question. Yeah, I think if you go back out around the other side was there, there's like a couple of like paths. How do you go just around the other side of where this goes?
And from the really different how I met collect a lot of information. So we have just made and then but the system has to do everything that we can follow them. That's what send them like they usually answer but not like have their I'll just send the link for the streaming and we'll start. And open. Where's open? So the guy will do the timing and show you the 5 minutes. Yeah, and then when it's okay.
10 would be useful.
Da tror jeg vi begynner, hvis dere er klare. Jeg skal bare si velkommen til huset. Jeg heter Aksel Borge, jeg leder noe som heter Sesam, som er en del av Bouvet. Bouvet er et konsulentselskap. Vi driver og gjør GDPR-prosjekter selvfølgelig, og hjelper kundene våre. Men Sesam er et produktselskap som har et verktøy som kan hjelpe til i implementasjonen. Jeg er veldig opptatt av GDPR, veldig opptatt av data, tilgang til data, sikring av data. Så dette er for meg personlig og for oss som selskap egentlig midt i blinken. Jeg tenker vi er heldige som får lov til å gjøre dette nå, og at vi som alle sammen som jobber med IT faktisk kan begynne å hjelpe de vi har data om til å få kontroll på sine data, som egentlig på en måte har vært et litt sånn fritt vilt fremover. Så jeg tenker at dette er veldig positivt, og nå begynner vi å nærme oss. Vi har noen måneder igjen, og det vi skal fokusere på i dag er jo folk som har begynt å gjøre ting, som er sånn fra på en måte analyse, og vi skal snart begynne å levere på dette også. Og det er jo veldig spennende å se, så jeg gleder meg i hvert fall, så håper jeg vi får felles nytte av dette fremover.
Hello. This is a joint event of our two meetups, also GDPR meetup and data engineering meetup. We hope you know a little bit about GDPR, but today we will have a deep dive into the problems regarding this new restrictions.
Yeah, this is Pavel, by the way. He's organizer at the Data Engineering Oslo, right?
Yes.
Group, and I'm facilitating Oslo GDPR meetup. And we are running this common event today because it was a lot of requests around technical perspective of the GDPR. We've done already at Oslo GDPR meetup, we've done already 3 meetups on different topics around GDPR. And our main goal as a meetup group is to have a neutral arena and a place where you can discuss things, where you can talk to each other, and we will try to do relevant topic for you. So we are really open. If you want to discuss some specific things, just send us a message or suggest something. Yeah. And for today, we have the agenda. We have 5 speakers, and it will be around 25 minutes each speaker. And you can ask questions right after the speaker finished. And we try to do 1 or maybe 2 short breaks, like for 10 minutes each, where you can discuss things. Yeah. And now I want to welcome our first speaker, which is Graham Moore from Sesam. Please, thank you.
Good afternoon. Right, I think we're there with the tech. Yes, just about. Right, great. It's great to see so many people here today. I hope we can put together some really interesting talks. There's a chance for questions, so please do ask. My name's Graham Moore. I'm head of product development here at Sesam. I've also been involved with our kind of GDPR task force, and this task force has been going around and working with different clients and customers to help them with their implementation of GDPR. And today I'm going to be talking about some of the lessons we've learned from that, some of the insights that we've had, and just try and pass on some of that those different bits and pieces, basically. The main focus I'll be talking about is how to kind of like really get going, how to bridge this gap between the analysis that has been happening and kind of actually doing something, and trying to understand, describe what does it mean to actually do GDPR. Okay. So what we've kind of seen and where kind of like the sort of the market has got to and where businesses have got to is lots of people have seen GDPR coming. They've been concerned about it, they've been kind of worried about it, they've panicked about it, and then they've kind of started acting and starting to take action. And a lot of that action really has been around getting lawyers and consultants to start kind of analyzing and documenting kind of where data is, what kind of criticality that data has to the business, and what kind of things are relevant to be shown to data subjects. And a lot of people have just been learning about the terms, right? What is this data subject thing? I mean, you go into these meetings and there's actually largely kind of an ignorance amongst many people of like just what some of these key terms really mean. And there's been a lot of education that's been happening around understanding what these terms are and what the obligations of an organization are towards these different stakeholders. So you end up with basically a bunch of reports and a bunch of kind of like documentation about the business in terms of data. And this is kind of what we're seeing, okay? So kind of once you've got that, what's going to happen next? So the other thing we've kind of seen at different places is that there's been quite a large separation between kind of a lot of this analysis work and then somebody actually going and doing stuff. We've kind of met organizations where you have an implementation team and they've kind of been given literally a bunch of PowerPoints and said, this is what you need to go and do, right? And with that comes basically a bunch of challenges that we've seen quite regularly. So one of the things that we kind of see is that when the implementation team takes this analysis, takes basically the documentation of kind of what data is where, and kind of takes that and compares it to what data is actually there, they start having a lot of questions. And one of the key things about this, and one of the things we've seen that's been very useful, is that the organizations who are most effective at doing stuff are the ones that really keep the different people involved in this properly connected. If you keep connected the legal, the analyst with the implementation team as a constant process, you basically can iterate much more effectively. And the other kind of thing that kind of is important here is that GDPR is never done, okay? It's not as though you can do all your analysis of where your data is and then go, right now let's build something and we're finished, okay? Because what's going to happen is, even after May, you're going to be buying new systems, you're going to be removing systems, you're going to be changing the nature of consent, and you're going to be changing contracts. And at that point, you're going to realize what we need is not these phases where we document and we build and we're done. You need to understand that you need a continuous process by which you can understand the nature of the changes, get them documented and get them implemented, and that needs to be continuous. So one of the things we kind of have been working on with people is to actually create an implementation strategy which gets them to learn and understand and build competence in continuous management and deployment of kind of GDPR implementation based on solid legal and sort of data analytics in essence. Why this is critical is that when you start doing the implementation, you end up having lots of questions. And I mean a lot of questions. The devil really is in the detail around this data. An analyst will go, yeah, we've got some customer objects in these systems. And then the implementation team, the data guys will go and they go, yeah, but like we have historical stuff, we have this stuff, we have like 20 copies of it. And they'll go, yeah, it's just a customer object, right? And it's like, yeah, but that's not true, right? Okay, the thing about this is really not just kind of, we think we have this stuff, it's like, what do you actually have, right? If you have a Excel document lying around sort of on your hard drive, that kind of counts, right? Don't do that. So one of the important things is that when these people have the questions, when they're going, we've actually seen this data, what should we do with it? That's when you need this process to be involved. This is when you need to be able to have an efficient way of going, we've got these questions, we need some answers to them for us to be able to act. So this is kind of where the high level kind of getting started, getting the teams together. But then when it comes to doing something, what is it that people, what does it mean to implement GDPR, right? There's been a lot of talk about knowing where your data is, documenting it, being able to show that you have the right procedures in place when people come to kind of audit your best practice. But that's really all that's one side of things, okay? The side that kind of we've really been focused on and that we've helped our clients focus on is the key rights that you need to deliver to the data subjects. As Axel mentioned, kind of the exciting thing about this is the fact we're freeing up this data for people, for you and me, to be able to go and ask for my data and to be able to use it in the ways that I want to use it. And to do this, we are basically helping people, or want to help customers and businesses to honor these different rights. I'm not going to dive into all of the different kind of things around GDPR, but I'll just highlight a few of them to kind of give you an idea of what we're really talking about. So first of all, we care about the right to access. This is perhaps sort of the most important rights, is the fact that I should be able to go somewhere in a secure fashion, to log on, to prove who I am, and then to be able to see the data you have about me and the reasons why you have that data. And if I've provided you with my consent, I should be able to manage and retract that consent. So the whole bunch of different capabilities here that are interesting. When I come in and I access that data, I should be able to get it in a machine-readable form. And if I can do that, then I'm free to go and give that data to other players in the market. Okay? So I should be able to get hold of that data. I should be able to ask for changes to the data that I provided to you before. Okay? I should be able to say, okay, I gave you this address and this phone number before, and actually they were wrong. I want you to change them. And by the way, if you've been giving that data to other third parties, you need to make sure that those changes are further provided to them. If I've given you my consent and I want to change it, I should be able to do this. And what's important then from you as a business is you have to recognize and understand that if that consent is retracted, you're then responsible for kind of tidying up, deleting, anonymizing that data. And again, if you've given it to third parties, you should basically, in essence, also say that data, the consent for that has gone now. You can no longer have that unless you get some new consent. So all of these things basically start to come together to indicate to a business there's a lot of stuff that needs to happen, a lot of kind of like machinery and workflows and data flows and user interactions that really come together to mean what it is to implement GDPR. The right to be forgotten is kind of like a meta level of consent. If there's no reason at all for having the data anymore, then I shouldn't have it. It should be gone. What we're starting to see, and as I describe these different things, what's important is, and I hope you can see, is that there's lots of moving parts here, okay? And there's lots of things that can go wrong if you do it manually. And there's an awful lot of work to do if your million customers or your 500,000 customers come along and say, I want my data today and I want it tomorrow and blah, 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 right? You don't want to be doing this all by hand. You don't want to do this all manually. You want to basically be able to automate this as much as possible. So here's a kind of like high-level logical architecture of there's kind of things we've been talking with our customers and clients about in terms of creating solutions to GDPR. And there are a couple of key things here. The first thing on the right-hand side is what we call the data access portal. This is the place that the data subjects, your customers and your clients, this is where they can come to log in securely and in some ways prove who they are. And this is there's a whole kind of talk around proving who people are, but in essence, what you need to do through this mechanism is to authenticate in a way that connects kind of you logging in with a bunch of data that that business has about you. So that could be kind of like bank ID, that could be maybe telephone, it might be email, but you need to have you have to have the correct level of trust and understanding that when people authenticate in that fashion, that they really are who they say they are. Once they've done that, in essence, that authentication mechanism also connects to an identification mechanism, right? So you can authenticate in a way which then connects you to an identifier, and that identifier is kind of maybe the handle for you as a customer or you as a person inside all the systems that these businesses have about you. And when you're kind of into that portal, you should be able to make requests for your data. You should be able to do all the things that I talked about. So you should do rectification. You should be able to see the consents. You should be able to see the reasons why people have the data about you. The engine itself, when we talk about having a GDPR engine, what we're talking about and focusing on is a piece of software or a bunch of pieces of software which can together help you automate as much of the process as possible around delivering the data to data subjects from all the different business systems that you have. Okay? So if that system is all just written in code, it might be kind of hard to understand how that works. So we also see that there's a key requirement here to start connecting the analysis that's happened and using that in a way that can be kind of fed to these engines to actually drive the automation. Right? You want to be able to take kind of all of the different angles that people have done in their research, all the different systems they've looked at, all the different data types they've been thinking about, and use that as a way to configure this engine. So that when I come in and ask for data, it kind of knows where that data is living in these systems and can use that to get that data. So what we've been doing with some of our customers is to kind of use our GDPR platform for doing this kind of thing. And we kind of look at how to create what we call this actionable configuration. Okay, this is a way we take this research and this insight around the analysis of the systems and turn it into descriptions which can actually drive a GDPR solution. In the middle, we use our SESM Data Hub. This is an integration platform for collecting and connecting data. What we really see is that GDPR largely is a combination of meeting user requirements through workflows and through data integration from multiple different systems. You have data about the same customer in many systems. You basically need to start collecting it together, shaping it up, and then delivering it out to customers in a secure fashion. With the Data Hub approach, we're able to specify and set up the way to collect the data from many different kinds of systems. In the Data Hub, we have basically a schemaless store of the data, and we can use identifiers to start connecting these different things together. This allows us to do the kind of the integration bit before it gets to the delivery part of the portal, of the platform. The key thing that we find is useful here is there's a lot of things about modeling in GDPR. And one of the key things we found very helpful is to come up with a very simple data model which describes data types, systems, and purposes. This looks like actually quite trivial, and at some level it is, but to actually get organizations to be able to do this effectively actually has taken a lot of work. In some ways, this is the kind of thing that people should have been creating, because with this, you can actually drive and automate nearly all of the processes around GDPR. There's a few bits of the model missing, but this is actually the key thing. And this key model allows us to deal with different kinds of issues. If we know what data types we have and which systems they live in, we know which data we should be collecting. If we know all the different purposes for why we have different kinds of data, we can understand that when you retract a consent, when you want to rectify some data, those changes can be automatically sent to the right system or sent to a system owner who can make the changes to that particular kind of system. And what we try to do with this approach is to, in essence, describe that process. What we found when working with people and working with is that the gap between the analysis and just filling in that very simple data model actually has tended to be quite large. And the insight really is that the main thing that's often missing is the reasons for why they have the data. Okay? With GDPR, you have to be very kind of specific and granular about why you have different bits of data. Okay? You can't just say, we've got some names and addresses and we might do some processing on it. You have to be much more explicit about why you have these different bits of data. So what we've seen is, and what I kind of would encourage you to do, is to kind of like look at and make sure that not only do you know where this data is, not only do you know that it's relevant, but you should know pretty clearly why do you have the data? What are the processes for which this data is being used? Okay, because that's something you need to expose out to people. You can't just say we've got this data. You have to say we're using this for this process. We're using this for this process. Okay? So a lot of people have like captured and documented data in like different kinds of tools. What we've done with our platform and our engine here is to, in essence, allow people to describe these different purposes and data types just in Excel. Okay. And although this is in some ways a simple and trivial way of doing it, we actually find that we can have enough consistency here. I just want to convey that you don't need masses of tooling to actually capture this core data. And if you capture it in a consistent and kind of reliable way, then you can actually use that to drive the automation of these different processes. So this is just a kind of like a couple of grabs from the different spreadsheets, and there are literally two you need to fill in, which really correlate to that data model that I showed you earlier. So the other thing that, from a high level, we've found as being very important from getting kind of good competence inside the organization is not to try and take all of the systems and kind of like start pushing them out kind of step by step, working kind of like one little step at a time with all the systems. What we found is a kind of much more effective way of working, and I kind of really would recommend this, is to really go, okay, we've got a portal, we've got some data. What is the process? What is our engine going to do, and how are we going to automate as much as possible getting data from these systems delivered out in a secure way through the portal? And through a secure way, we mean kind of it's encrypted, and there's kind of users have keys and all this kind of stuff, so that people are kind of ready for May, okay? So that they can say, we have a portal, this is where you can come, we have the key data flowing through this thing and being able to be accessed. The other systems, the other stuff that kind of is maybe less critical, less obvious, you still have to do it, but you can do that at a different speed, okay? So by doing things in this kind of end-to-end fashion, by thinking about what configuration do we need, what systems do we care about most to start with, how do we deal with it, how do we deliver it, you actually work end-to-end, and you get people much more engaged with all the things they need to do in terms of the challenges they're going to have over time. So working on this notion of end-to-end solutions is, I think, really, really important. You really start asking the important questions then. You really start asking, do we understand our process for how we deal with new data, new systems, and so forth? So what we've been doing with with some of our customers is to kind of set up this end-to-end solution, and I'll just give you a quick look at kind of what a portal needs to do. Okay, kind of what are the key things that we think are important with delivering this kind of solution through a GDPR portal. And the authentication thing is obviously critical. The fact you can, in essence, authenticate through secure means with some degree of two-factor authentication, and in this case, it's phone number. And getting one-time codes, securing the access, making sure that people really are who they are when they want to hook in there and get their data. So here's me inside a prototype for Hafslund, and one of the key things here is we focused on is people will care about their data, but they also care about why you have their data. Okay. So here on the left, we're showing the kind of the formal, which is kind of like the reasons for the data, all the different kinds of reasons, and describing those reasons to them in simple, clear descriptions. And if it's a consent-based feature, that they can basically come in here and request that consent is retracted. This portal application is hooked up to our integration platform, and the request for that consent change is sent as data into that platform and then can be actioned upon. So it can either be actioned upon automatically by kind of deleting data if there's no use for it anymore, or it can be sent out to people to act on in a kind of automated or semi-automated fashion. When you actually go to look at your data, you see the different data that's been collected from the different kinds of systems. So we've set up the integration platform to consume and collect data about customers from the many different systems in the business. That data is connected together in the data hub. And when I've made the request here, it's actually generated me a unique private public key pair in the client application. And it's sent the public key up to our portal. and that key has then been sent into the hub, and that public key has been used to encrypt the data on a per data subject basis. The data flowing back then is basically not able to be decrypted and viewed by anybody or any browser application other than the one that sent it the key. So this private key is stored here locally. So this is a very secure way, and a kind of a key requirement to a platform is that you can securely ensure that only the right person sees the data that they should have access to here. So just to summarize a little bit, that the analysis that has been done really is a great starting point to connect into a technical implementation. I would encourage you, whatever you're doing, to try and take the analysis that people have done and turn it into something that can kind of be the configuration to help automate your process. Whether you're writing stuff in code and kind of using Jira, whatever you're doing, think about connecting it up. Because if you do that, you're able to then also have a much better discussion with the people who have been doing some of that analysis, which may not be the implementation team. Okay? You then have a common vocabulary, a common meeting point where you can start discussing stuff. The other key thing is to try and work end to end, to try and go, okay, what's our key data? How are we going to actually deliver it out through the portal? How are we going to give data subjects access to the data that we have to give them access to? Keep open those lines of communication between the different stakeholders, between legal, between the analysts, and between the implementers. That's really the only way to be fast and efficient. And from that, you should be really deriving a process which you can kind of document and put into place. Say, okay, as we deal with change over time, this is what's going to happen. These are the people who are going to document this, they're going to describe it like this, we're going to implement it, we're going to convey it to our subjects like this. If you want to give a try to our platform, then you can pop along to this URL and have a look. If you want to talk about it a bit more, I think Axel will be here during the break. And I think I can say thank you very much, and if there's a couple of questions, I can take those now.
Do we have questions? Not yet? Okay. Thank you very much, Graham. And our next speaker is from Narashima from Shipset, please.
Yeah, that's right.
Yeah, welcome.
Thank you.
By the way, I plan to do some pictures and publish them on the meetup group. Do I have your consent? If not, just tell me. Yeah.
Good afternoon, guys. Can you hear me? Yeah. Can you guys hear me? Can you guys hear me? Oh, that's good. Stand here for the video.
Yeah.
Okay.
We also do live streaming on the YouTube, and you have already link on the meetup group, so you can send it to someone later.
Good afternoon, guys. So before I begin into my talk, I would like to know how many of you have started preparing your organization for GDPR? Could you please raise your hands? Oh, cool. Did you guys have some fun during the journey? Did you find some interesting technical challenges? Oh, looks like no one found any interesting technical challenges. So at Shipstead, we found quite a lot of interesting challenges, and I'm going to share some of these challenges and hope you guys find these challenges exciting. So who am I? I'm Narashima. I'm a Group Technical Program Manager for Privacy. I lead privacy engineering efforts across the organization. So I'll talk a little bit more about the privacy engineering team a bit later on. So here's a quick agenda of my presentation. So I would like to start with a background. So what is and how we organize privacy efforts at Shipstead. And then I talk about two interesting challenges and the approach that we take to solve those challenges. And then I would like to conclude this presentation with the summary of our approaches and then how these approaches help solving the challenges. Yeah. So what is Shipstead? So how many of you know about Shipstead? Wow, so almost everyone knows about Shipstead. So before I provide the official answer of what is Shipstead, I would like to provide the scale of Shipstead. So we have 200 plus million monthly active users worldwide, and we are collecting more than 700 million events per day, and we have more than 20 plus billion page views per month. So how Shipstead managed to get this kind of scale? So the answer is through Shipstead's group of companies. Shipstead's group of companies can be categorized into three parts. The first one is media houses. So we got the biggest media houses in Scandinavia. So many of you already know about VG and Aftenposten in Norway. When we talk about marketplaces, we have them all over the world. And in Norway, we have Finn, and in France, we have Leboncoin, which is the second largest used site after Google. And the third part of the company is kind of an experimental part of the company where we invest in new markets. Probably you're familiar with Lendo. So all those companies together generate a lot of data, and together we have 200 million monthly active users. Hence, it is important for us to care more about GDPR. So if you're interested in knowing the technical details of how we collect different type of events and how we process different type of events, then I strongly recommend you guys to look into the videos videos of Java Zone 2016 and Java Zone 2017 given by our speakers. So we have one speaker here, Hakun. Moving on to how we do privacy at Shipstead. So at Shipstead, we organize privacy as a triangle. So we have a product team, so who try to understand privacy from a user point of view and create the user interface for our users. And we have a privacy engineering team who builds services and tools to embed privacy by design into Shipstead products. And we have a privacy office who help us privacy from a legal point of view and who provides all the legal guidelines. Before I introduce the challenges, I would like to make sure that we are aligned with respect to the GDPR terminologies. So recapping a small recap on GDPR rules. We have 4 main characters within the GDPR world. Either you are a data subject about whom the information is collected, or you are a data controller who collects the information about the data subject, or you are a data processor, a service provider to a data controller who just follows the instruction of a data controller, and or you're a supervisory authority who regulates what data controller and data processor can do with the personal data of the data subject. So in the GDPR world, everyone takes one of these 4 roles. Yeah, recap of rights of data subjects. So the previous speaker has already talked a little bit about the different rights. So in this presentation, I'm going to focus on these two rights, right to access and right to erasure. So what are the different technical challenges that we face when we want to implement the right to access and the right to erasure in our system? So right to access. So right to access, or we call it simple data takeout operation. So think about a scenario like you are a user of Fin. You go to Fin and then you ask Fin like, hey Fin, give me all my data, right? So that's basically the scenario that we are talking about it. And okay, so Fin receives this request. So then Fin thinks about 5 logical steps. The first step, how do I verify the identity of this user? The second step, okay, so this seems to be a legitimate user. So I need to distribute the request to the appropriate data stores, which host this user's personal data. And then the third step is like, okay, so I wait for this data stores to execute on this request and then collect all the results back from this data stores, and then aggregate all this results and then give it back to the user. So these are 5 simple steps, but are they really simple? So we have quite a few design choices to implement the right to. So at one end of the spectrum, we can go for fully manual solution, where humans are involved in every step. And then we do have option of going to fully automated solution where we don't have any humans. So we have automated systems that can execute each and every step. And Shipstead is more towards automated systems, and I can talk about the different challenges that we encountered while we built this automated system. So, so think about the scenario: the user goes to Fin and asks for all the data. The Fin verifies the identity of the user. Now, the next step, what Fin needs to do is like try to identify where all his data sets are located. Fin has more than 100 data stores, and then how Fin finds out, okay, so where this data, where we have the data about this user. So where is this data located? And that's the first challenge. Assume that somehow Fin magically solved that challenge, identified the data stores that host the end user's data, but Fin needs to solve the next challenge, which is a distribution challenge. So all these data stores are heterogeneous, and there are a lot of legacy systems. So how Fin is going to distribute the request to these legacy data stores and heterogeneous data stores? That's the distribution challenge. The third interesting challenge is the coordination challenge. Assume that Fin somehow managed to distribute the request to 50 heterogeneous data stores. But how Fin knows that, like, okay, all these data stores complete the tasks, complete the request or honor the request. So if you guys have worked with Zookeeper, then you understand the problem that I'm talking about it. The next interesting challenge is like, assume that Fin has solved the distribution challenge and all the data stores have completed their job. But Fin data sets with a size more than 50 gigabytes, and Fin needs to think about, okay, how do I aggregate them? And so think Fin has again solved this challenge, and now it goes to the other interesting challenge, which is download challenge. So Fin needs to let user access his data. So I'm a loyal user to Fin. I've been using Fin for more than 15 years. So Fin accumulated more than 50 gigabytes of my data set. And how do I distribute that 50 gigabytes of data set to the end user? So that's an interesting problem. So these are the different challenges. The last but most interesting challenge is failures. So every step, every challenge also includes failures into account. So how we are going to deal with failures, it's an interesting challenge that we need to solve. So moving on to the next scenario, right to erasure. So this is nothing but a scenario where the user goes to Fin and then asks for delete all my information. So whatever information that you have about me, just go and delete it. And we have an interesting characteristic for a deletion operation. The interesting characteristic is the deletion logic differs from one data category to another data category. So if it is a payment data, then we need to go for archiving. That's our deletion logic for payment data. If it's a behavioral data, then we need to go for anonymizing. If it is profile data, then we completely remove from the system. So there are like different types of deletion logic depending upon the data category. So again, the logical steps for Fin would be like verify the identity of the data subject, and then again find and distribute the deletion request to the appropriate data store. And then the unique characteristics for a deletion operation is resolving dependencies. For example, our payment team, right? So our payment team has payment data. If I want to execute the deletion logic for payment team, which is archiving, so I depend on other teams' data set, like profile and also behavioral events. So I want to make sure like those data sets are available before the payment team executes I want to make sure that those data sets are available at the time of payment team executing its deletion logic. And the last step is like, after you resolve the dependencies, then you execute the deletion logic. Yeah, so if I compare these two scenarios, like the common thing between these two scenarios are like, so both the scenarios involve verification of identity and find and distribute challenges. Also include failure challenges and also include a spectrum of design choices. So the things that they differ are like for right to access, I need to perform a collection operation and aggregation operation and then provide a download link. Whereas for a deletion operation, I just need to resolve the dependencies between the teams and each team focus on executing the deletion logic. So yeah, resolve dependencies challenge. So that's what I mentioned before. Like team X depends on team Y's data sets in order to execute the deletion logic. And how can I resolve dependencies in case if there are like number of teams that depend on several other teams. So yeah, deletion logic challenge. So am I correctly anonymizing the data set? So how do I quantify the correctness of my anonymization algorithm? And I have an immutable store, how do I delete it? So these are like a different type of deletion logic challenges that we need to resolve. So ShipStead's approach to address the challenges of rights of data subjects is as follows. So we built a simple topic-based pub/sub system. So how many of you know about topic-based pub/sub system? Okay, so there are quite a few people know about topic-based pub/sub system. Yeah. So we built a topic-based pub/sub system called a privacy broker. So the topics here are the different rights or the privacy controls that we want to offer to the end users, and publishers are sorry. Oops. Yeah, publishers are the different front ends that provide the user interface to trigger the various privacy operations. Like think about like settings page, and then you go and then click a data delete button or data takeout button, and that's basically what we call it as publishers. And subscribers are the different data stores and data process belonging to the data controllers. So we have written a technical paper about how Privacy Broker works. So if you're interested, like here's the reference. So you can download the technical paper and read about the architecture of a Privacy Broker. And I would like to show you some screenshots. So this is the interface for Privacy Broker. So you have a publisher who we call it as a front-end services, and then a subscriber services. So depending upon the role that you play, so you go to either publisher mode or you go to subscriber mode. So assume that Fin wants to take a publisher role. Then they enter the publisher configuration page, and the first two fields indicate the publisher information, and then the next three fields indicate the information required for providing on-call support. And the next two fields indicate the configuration for communication endpoints, and the last field indicates like which identity provider does this user belong to. Like as I mentioned before, ShipStead is a group of companies, and then every company has its own identity provider. So we need to identify which user belong to which identity provider. Hence, you choose that from user realms. So, so this is the subscriber configuration page. So you start with creating a group subscription based on the identity provider, and then you contact the individual member of the group. So this is basically your data store configuration. So here you mention the request operation. Here you mention the topic type. So the request operation, you say like, okay, so are you interested in a data takeout or are you interested in a data deletion? And then you say like what type of call that you want to make to the data store. So is it a synchronous API call or like a non-synchronous call, or is it SQS or is it SNS? Mention it here, and then you configure the endpoint here, and then you configure the authorization resources here, and then you tell like, okay, in case of failures, like how many times that I need to retry with this request, and here you tell them how long it takes for the data store to honor a particular request. So these are the configuration details that you need to provide as a subscriber. And then the magic happens, then the privacy broker helps you to resolve the right to access and right to erasure scenario. So, so a quick summary of my talk. So we have identified the different challenges involved in implementing the right to access and right to erasure scenarios, and to solve verification challenge, we use the identity provider, and to solve find and distribute challenge, we use privacy broker, and to solve a collect aggregate, again we use privacy broker, and to resolve dependencies, again we use privacy broker, and individual teams execute their deletion logic. And for download link, again for sharing the download link to the users, we again use privacy broker and then front-end clients. So, so this is the approach that what Shipstead has taken in order to solve a right to access and right to erasure scenarios. Yep. Any questions? Yeah. Yes, we already have onboarded. We have onboarded Finn, Vege, so it's already working now. So yeah, it's in production. Yeah.
Are you setting up separate instances of the system for each company, or building a central system?
So we are building a central system, and then this central system will be used by different companies. Like I mean, Vega and Finn are two different companies, right? So and then both these companies use privacy broker. So in that case, so that's so you have publisher, right? So Vega will be one publisher, and then Finn could be another publisher if both of them are in a different account, I mean different IDP. Yeah.
I guess my question is, will people contact Vega and say, yeah, Shipstead, can you use all my data?
So, so I think you have something called SPID. So you log into SPID. So that's the identity provider for Vega and Finn. It's a common identity provider, meaning like you have a common account between Finn and Vega. So you log into your account settings, and then you go to a privacy settings page in your account settings, and then you go and then click delete. So then that request goes to all the it just fans out. It goes to the broker, and then the broker in turn fans out the request to the appropriate data stores that you have configured while you are onboarding to the broker, and make sure the scenario gets completely implemented. Yeah.
For the publisher and the subscriber control panels, do you expect engineers from the media houses and the other companies to configure this, or do you expect a non-technical user to configure that?
I think we expect the developers to configure this. So it's pretty much like an self-service thing. I mean, like if you have used AWS, then you know like how it takes to onboard to a particular service, right? So we want to follow the same strategy. So so we are trying to go for as much as self-service model.
What happens to data in backups?
That's a very interesting question, actually. So, so we have, I mean, as I mentioned, like we have a deletion logic for different type of data categories. And then for data in backups, so it also depends upon what type of a data and then what type of backup are we talking about it. So are you talking about CDs or are you talking about cloud services? So depending upon the
any kind you have.
So I think let's say like if the user wants to go for complete deletion of account, right? So the natural thinking would be to delete his backup data as well, right? But then, so do we have a list of all the backups is the first question that I would ask myself. So following the fine challenge that I mentioned before. So once we have the list of backups, then I think it would be depending upon the mode and then depending upon the type of a data, then we choose the appropriate deletion logic to do the execution deletion.
So you're gonna try to delete it from the backup.
It depends, right? So it's an immutable store or like immutable store. So there are like a lot of factors that we need to take into an account to think about it. But the good practice is like if you're taking backup, then have a good retention policy over your backup. So that's the approach that I would recommend if you're going to start taking backup now. But what happened to the systems that are back 15 years ago? So it's an interesting question to deal with. Yeah. Yeah.
So how do you deal with personal data which is stored in cookies, which is not in the loading system?
So that's completely outside our boundary, right? So that's on the client device. So
but you're doing identity calls on that, aren't you?
So we try to identify the user based on the cookie information, especially if it's a non-logged in user. So cookie is one of the ways that we use to do it. But then deleting the cookie information is something that it's a tricky problem, right? So that's something that what we are looking into now, actually. Yeah.
The aggregated data which is presented from these 100 data stores,
Yeah.
are they presented in a uniform format?
It's a very good question, actually. So all these data sets that that we have about the users are completely different types, right? So you have images, you have videos, and then you have payment information, and which is in a JSON format. So I mean, like all these data sets are in a different format. So what we try to do is like we try to create a nice HTML page that describes the these different data sets, and when you click on this particular data type, then you know that okay, so this is basically the video files. So then you just get the format in which you uploaded it. So that's, and then we think about having like a zip file, and then if it's going to be payment data or like your profile information, so we probably want to provide you back in a CSV file. Yeah.
So basically you host the same different way.
Same data, we do a data format transformation because like there are some requirements with respect to how the data needs to be handed over to the end user, right? Because we also need to think about like 65 plus, 70 plus users who have not, age-wise, who have not used computer systems, right? So how do they understand it?
Your whole data set for one user and just present the data set in the other web page.
That's something that what we are thinking about it actually. Yeah. More questions?
Thank you so much, Narshima.
Yeah.
Thank you. And then the next will be Andy Petrella from Kensu, and after his talk, we're going to have a 10 minutes break.
One, two. Can you hear me right? Can you hear me? 1, 2. Ah, better. Hello everyone. So I've been told that I have 25 minutes, going to be pretty challenging for me. I gave this one in 50 minutes generally. So I have two options: speak twice as fast as originally, or skip a few things. So I probably skip a few things. So just stop me if I speak too many things. Though. Anyways, there will be some questions afterwards. Oh right. But I don't know if you took the GDPR already. Anyways, so I'm Andy Petrella. I'm coming from Kensu. I'm going to talk about data science governance. I don't know if any of you already have heard about data science governance, or at least data governance. Data governance. Raise your hands. Oh, seriously, more than that, right? Raise your hands. Don't be shy. Okay, data science governance, maybe. That was it. All right. So that's why I'm here. Also, we'll try to put this data science governance perspective into with GDPR, of course, and essentially the accountability principle. Do you know about the accountability principle in GDPR already? Who doesn't know anything about that? The accountability principle. That's awesome. I can skip that part. But I will try to, explain how data science governance can bring some added value into the business thanks to this concept. Right. Does that work? Right. So, a few things about me. So, I'm the creator of the Spark Notebook. I'm a mathematician originally. I'm running startups since 2010. This one now, Kensu, is in the US right now. So, I'm raising a fund currently, a round, sorry. I'm regularly speaking with, talking at Strata events. I don't know if you know Strata. I'm a member of the committee. I'm writing books. I'm doing things about data for more than 15 years now. My background isn't just spatial. I worked a lot with government, especially defense though. I worked with Norway Defense, by the way, back in 2010 or something. So the different topics I will try to cover today are some thoughts about data science governance, what it can be, how we can achieve it, the GDPR accountability principles and transparency principles. I will try to skip them too, and a few words about how it can bring some business advantages. Right, the camera is over there. Some thoughts on data science, very quickly. Machine learning. So most of us think that data science is machine learning, right? So it's all about math, it's all about algorithms or whatsoever. Actually, I think totally differently. Actually, machine learning is not new. First, it dates from the 50s. It has some winter as well in the 70s because they didn't know how to make it work with the computer they had back then. Then they discovered backpropagation. So, oh yeah, now we can do things about neural network and so on and so forth. But actually, the thing is that it was already introduced into compute and software since 90s, 2000. So it's like almost 20 years ago, right? 20 years. I was back in university back then, right? So I was still trying to learn anything from my teachers. So it's pretty old. Data science cannot be only machine learning, otherwise it wouldn't be buzzed for the last couple of years. So actually, data science is probably much more machine learning plus engineering, maybe. Do you know D.G. Patel? He's the first CTO of the United States of America. Right. He's not there anymore, right? He was there with Obama, but he was the guy who coined data science. However, really, machine learning plus engineering is when, if I go back on one slide, so is really 2008 when we integrated machine learning stuff into software. So it's really when we took some heart in papers and we bring them to softwares. And I'm not talking about Jupyter or algorithms. I'm really talking about all softwares like SAS or even older computing softwares. So really, it was at the time where we added engineering in the mix. And it's even more important now that we are adding distributed computing into the mix, right? What we call big data back then. Because now that we have distributed computing, we have more and more engineering involved into machine learning or whatever you call it, processes. However, data science cannot be only engineering because it dates from 2008, and data science is very buzzed since the last couple of years, as I said. So actually, data science is very interesting when you add experimentation into it. Nowadays, we have a lot of data available. I'm not going to talk about it, so it's pretty much obvious right now. but the data is available. We have so many tools, so many frameworks, we have solutions. We can do a lot of things. And actually, 90% of things we can do, we don't even know what will be the result. So it's like totally different from BI. When you have a problem, you want to solve it. Experimentation is more about, I'm going to learn from the data. I'm going to understand what's in there, and then I will try to do something about it. Because most of the data are new, right? If you think about social network, Twitter or whatever, these data are new, so they are not, there is no 30 years of experience with this data, so we still have to learn what we can do with the data, what we can extract from it. And essentially, experimentation leads to discover new insights, and then there is the idea of new businesses, and then this fantasy maybe, but at least trying to get information from data is the most important fact, right? Data is nothing if we don't extract information from them. So now is the time when we want to extract more and more information about the whole data that we have, and for this we have to do experimentation. To do experimentation, we have to have a lot of different data, and we have to have the computing power, for instance. So all of these makes data science. And actually, if I recap the whole thing, then we have math, we have engineering, we have ETL databases, whatever, then we have creativity. And this is why when I come to enterprise, or even startup, I say that actually everybody here is a scientist, finally. Because if you are not part of this, one of these components, you cannot be part of the team, right? So you're a data scientist, but maybe you're not a machine learning guy. Okay, that's fine. The thing is that actually you're a data scientist because you are doing things with data. You are processing it, you're extracting it, you are transforming it, where you are learning from it, whatever you do with it, you are generating activities on top of the data. You are applying functions on that. Oh, my laptop is running out of battery. Anyways, and the thing is that it's interesting because Google pretty much is saying the same thing as I do. Actually, machine learning is this little black square box in the middle of everything, right? If you read this paper, I highly recommend it. Is a hidden technical depth in machine learning systems, right? They say, okay, so the ML code is over there. Everything around it can break this thing. Okay, so data science governance. It looks like I'm deviating quite a lot from the subject, but let's get back to the subject then. Okay, let's talk about data pipelines. Data pipelines, we generally think about the end-to-end process, right? So we take data on one side, and we generate data on the other side. And maybe there will be actionable data. Generally, they will be used for business reasons or whatsoever, but generally we think like that. Actually, data pipeline is more about several segments we're putting together. And the thing is that the very interest with data pipelines is to take decision at the end, right? So we wouldn't process data if we don't want to take decisions, right? Why would we do that? Consuming resources for nothing. There are several ways to do this, cars and so on. So no, actually, if you process data, is to take decisions. And the thing is that data pipelines is, as I said, just segments stitching together. And these different segments can be reused in different places. You can take some data from a database, you extract some information from it, you store it in a file. This file will be used by yourself to do some other, I don't know, maybe segmentation whatsoever, but this file can also be used by someone else. But what if you at some point change the pattern in this file? You know that how to apply the different transformation afterwards in your pipeline that you see as a single line, but what about the other guy that you don't even know about, right? You can start understanding what are the differences between pipeline and actually thinking about segment. Actually, really pipelines are just really cut and worn, interleaved and whatsoever. And the thing is that at the end, we have still to take decisions based on the computation we have made on the data. There are still some decisions taken on the data. So when you think about all this, I mean, as a data scientist, at some point, or data science team, as I like to say, at some point you have to be, quite anxious about what you do, because what if at some point I'm using some data which is changed because I don't know the original source of my data. I don't know from where it's coming from. I have to be really aware of what data I'm consuming and from where it comes. So if at some point it changes, then I know how to react to these patterns. Right. So the different source of anxiety, I provided one already. Like, sorry, if someone is changing the process upstream, but also this is really engineering. But what if the data themselves are changing. You deploy something, you have a pipeline, and at some point, the data are changing, right? It happens all the time, right? So because there is a social, economical event happening somewhere, there is, I don't know, a earthquake or, I don't know, a bankruptcy somewhere, and then the data are changing. How can you assess your model or your decision based on this fact? Because maybe your process upstream is filtering all these events because they are considering them as outliers. But actually they're not. They are just new patterns that you know of. So how can you react on this? How can you make use of this new information, right? It's real information, not new data, no new information into a system where everything is interleaved because we want to reuse as much as we can. Actually, you really need debugging, right? In engineering, what we do is, unit tests, functional tests, whatsoever, but how can we test against old data? How can we test against new patterns? It's very hard to test about things that we don't know, right? So how can we, really debug our pipeline if we don't have a big picture? If we don't know from where the data is coming from, where it goes, what the decisions are taken, what is the feedback, right? That's really something which is missing nowadays in data science, and this is really something which is needed because now data science is extracted from university or whatever and really put in front of, on the front stage, and now we have to make it, I don't like the term, but it's true, enterprise ready. So data science governance, if I take the definition of data governance, it's a one-liner. So it controls the data. It controls the data meets persist standards and involves monitoring against production data. If you think about data science governance being activities on data, right? Then you control that data activity meets persist standards and involves monitoring against production data activity. So you're looking if your processes are still meeting the right quality. I'm not talking about number of CPUs, the CPU load on memory taken, but actually really metrics about what kind of patterns it takes and patterns it generates. And that is going to give you enough power to be able to process in production. Because otherwise you have to have the data. And 99% of the time you will say, the answer will be, I can give you anonymized data, or I can give you samples, or no. Generally is no. Sorry. So that's why if you think about data science governance, you have to think about data activity to be, a kind of information which is composed of multiple information. What is the technology that has been used? What are the users that have been involved in the process? What are the systems involved in the process? What is the data, of course, that you have used and generated? And what are different processing steps that you have applied to the data? Let's take one of them. The one that I like pretty much is the systems. Nowadays, we like about containers. We like everything about it. Kubernetes, Docker, Mesos, whatsoever. But what if at some point you change the configuration of the container of a job that you deliver, right? What if your approximation, which is often the case now with big data, is actually relying on the number of CPUs that you have, or the amount of memory that you have? Then it can change the quality of your data. So the system is also very important in order to have the full picture. So governing data science generally is who does what on which data and where it is done. What is the impact of a process on the global system? What if at some point I'm filtering out some event that I consider to be outliers? What is the impact downstream, right? If you do fraud detection and you think that you're actually doing user segmentation and your data is actually used by two different systems afterwards, fraud detection and segmentation, then you're screwed. Because actually you remove information that will be probably very highly valuable for the fraud detection, but not for user segmentation, of course, because they're not really real users you want to consider. And of course, what are the performance metrics? Again, I'm not talking about CPU, I'm talking about R-square, I'm talking about metrics, I'm going to be talking about distances, I'm talking about these metrics that are assessing a model or a data to be of quality. So ultimately what I would say is that just forget about data quality and think about differentiable quality. Differentiable quality is really about how can we qualify the quality of a function. They can be derived and then optimized, of course. So ultimately, what I'm talking about is really continuous integration. I have 10 minutes. That's awesome. More than I was expecting. So finally, I took twice as fast as possible as generally so far. So it's really thinking about continuous integration for data science. It's really about information that you want to have in order to debug your cases. Of course, the slides will be available if you like, so I'm not going to go over the whole thing. So how can we achieve then data science governance? Because it sounds like a big piece of cake, and it is. Like data governance, by the way. So the challenges are, nowadays there are so many tools. We are talking about processing activities from the beginning, right? And we have to control these tools. Think about Excel, think about SAS, think about SAP, think about CRM, think about those things, right? Those are the things that you want to control, right? The number, and again, think about scikit-learn, think about TensorFlow, think about Spark, think about whatever you want to do with the data using whatever technology you want to use. And of course, nowadays with data science, the number of processing is exploding because we want to do exploration, right? So the problem is, if you want to apply something with GDPR, I'm already going a little bit faster forward, it's going to be pretty hard to ask a data science team, okay, tell me exactly what data you need in order to optimize my segmentation. Please tell me, because otherwise you can't. You won't have the data. Man, it's hard. I mean, I don't know. Please let me just try and then we will see. And the answer will be no, because I can control what you do. The model will be, I don't know where, and then I will have a file at the end and I can control. If you actually, did you use the consent, by the way? I don't know. The script is somewhere. I can't even remember what it is, and the result that's out there, and then we said already cop and bun, by the way, is gone. So actually, it's very hard to do a control-first approach. That's why I recommend to have a kind of monitoring approach, where we have things that is listening from the way people are using the different tools. But of course, there are more and more tools. There are number of processing which is increasing, so we have more and more information, so we have to filter the false positive, for instance. Oh, this guy is using privacy data. Oh, this guy is using privacy data. Actually, 99% of the time it's fine. But we have to detect the 1% which is important. And 99% of this 1% is because the people didn't know that he wasn't, allowed to do it. And we have to filter this out as well. And of course, it's not about talking about big data, distributed systems, or whatsoever. We have to talk about as well mainframes, right? Mainframe or SAS or whatever tools around that we have to control, right? These are 95% of nowadays enterprise architecture, right? So we cannot put them aside saying, okay, I'm going to refactor the whole thing and it's going to be fine afterwards. Well, if you know a little bit about continuity of business, then you know that you cannot say this. So getting the data then is very hard. So you have to plug in pretty much everywhere. You have to get the information. You have to understand what data is in, what data will be out, who did what at what time, and so on and so forth. You have to collect lineage, of course. This is very important, but not enough. You have to collect statistics about the data. Again, I'm talking about patterns, right? So I'm talking about the impact of a data pattern on the model, on the output of the model, right? So you have to understand, okay, how can we have a proxy on the data pattern? What kind of information can explain me how the data is deviating so that I can understand how my model is deviating from the truth, right? These are information you need to collect. And these are metadata, right? You're not asking about data per se, you are just asking about metadata, of course. So getting the data is pretty tough, but it's very important. However, when you have it, then you can connect them and make fun of it, right? Because actually you have a very large data set, nothing very privacy or sensitive in it, and then you can create a cartography, so map, right? Then you can learn everything about it, and then you can apply your algorithms on top of it. And this is where the fun part, is in data science governance. So mapping is an obvious outcome of it, but actually there are many others, like impact analysis, dependency analysis, right? You can understand, okay, actually this guy is using this data, but actually this data is pretty close to this one, which has been cleaned already, so maybe we can reconnect the dots over there instead. Recommendation, if you want to do, I don't know, next best action, then you can say, oh, actually, this data is much more complete than the data you're currently using, because we know how user segmentation or next best action has been done in the past. So you can share knowledge based on this information. So GDPR, so you know everything about it, so I don't have to talk about it, right? Accountability in principle, good, 5 minutes. Transparency, no, I'm skipping, man. I mean, go move faster. Transparency is okay. So how data science governance can fulfill the gap here? By collecting activities and connecting activities, we can generate at least part of information required for the process registry. We can say, okay, this is information which are part of the business lines, right? So you can connect information, and then we can actually present a summary information. But if you have to troubleshoot, right? Because at some point, if you find a problem in the usage of privacy data, you have to troubleshoot it, right? And this is where you can have no information, right? We can now troubleshoot how the data has been used now and not in the past. One thing that I like is transparency as well. Actually, with data science governance, it's very clear that you will have transparency because you know exactly what tools have been used, what kind of model have been applied, and so on. So this is kind of information you can extract from this kind of information. And for instance, if you want to do a mortgage and you want to take a decision on top of it using a deep learning algorithm, right? You pretty much know now that you cannot do it because at some point you cannot explain back to the people that you refused, the mortgage. Well, actually, you have been refused because the system says, and we cannot explain really what the deep learning algorithm has produced, why it did come with a solution. Anyways, so these are kind of things you can do with the data science governance. And to finish this, right, how it can be helpful for the business. Actually, if you can connect, the KPIs of your business with all the processing that you have in the data, because actually all the decision made in the enterprise is not only gut feeling, it's also made, based on, these fancy charts with pie chart and whatever. These are data, just presentation of the data. These are KPIs, and then from there, from this information, they try to optimize, the enterprise, right? Actually, if you can connect these things with all the data sources, then you can try to have enough information to optimize the whole thing, and then you can see the impact of changing the data at first, and changing the data at first, and then what will be the impact at the end. And this is how you don't want to match in the data if you want to be very creative, right? You don't want to match in the data because then you're just following. If you want to be very creative, you have to adapt the data. You have to be able to say, okay, if we change this in the pattern of the data as an input, then I can increase my sales. That's the kind of thing disruption is. You don't want to adapt. You don't want to match. You want to adapt. 2 minutes. And what we do at Kensu is we want to take the ID first. I'm happy to discuss about it, just to show this kind of things. So what we do is actually we do almost all the things that I explained so far with a kind of open API. So we allow people to publish metadata about their activities, publish onto our platform. Then we have all the fancy stuff we need in order to extract the right information for the different people, like the DPO, understanding, okay, has the consent be used everywhere? Or do I really need to run a DPI there? Or for the manager, how the different metrics are behaving in the last few weeks regarding this and this process, and so on and so forth. And for engineer, we have recommendation systems like, okay, this data is probably better than this one. This model has worked better in the past as the one that you are currently trying, but maybe you can try, but then we will be able to do A/B testing, and so on and so forth. So we have a full product about it. So I'm very happy to discuss about it. I'm not here to do a pitch, but anyway, so you know what we do. We are doing data science governance. Thank you. I think I still have 5 minutes. Awesome. Yeah.
If you were to summarize data governance in one sentence, what would that be?
Govern activities. If I want to summarize data governance in one sentence. Yeah. No, it's hard. Actually, really in one sentence, what I would say is understanding what the people are doing with the data. Right? This is really what you want to do. right? Actually, there is a really good example, like controlling the speed on the road, right? If you do, like they do now, right? So it's not really optimized. You have a flash, something, a radar, it takes the speed once, and then if you know it, then you know that you have to, slow down before the radar, and then you move on, right? Actually, a good radar is something which is taking the information from one point to the other, right? And this is really what governing is. It's not taking information from one point, think about data, but actually the whole system in order to see if yes or no you have been against the law or not. Of course, we may not want this, but actually if there are regulations with a 4% fine at the end, I mean, other questions? Great. Snap.
You have to gather consent in order to use data for building deep learning?
So do we have to gather consent to build deep learning algorithms? Well, actually, there are a few cases where you can't simply run them because you cannot really transparently explain this. And again, it depends on the data you're consuming, right? If you don't consume any kind of personal data, then you shouldn't be it shouldn't be mandatory. However, as you may know, right? I mean, what is really privacy data and sensitive data, right? I mean, data contains part of information, whatever it is, right? It's really the combination of data that will say if yes or no it contains privacy or sensitive data. It's not the data per se, right? So if I combine 5 or 6 or 12 data sources, maybe the first one contains, I don't know, maybe maybe just write the IP, right? And it's the dynamic IP. Maybe I will be able to reconnect to the individual. The IP is already targeted as a privacy anyway. But again, this is where it's hard to answer the question beforehand. This is a perfect example. Can I use deep learning? Can I use this data? I don't know. It really depends on the outcome. Yeah.
So if you're using deep learning and you're building a system that was impossible to retrieve the actual data from the model, you're using a bunch of data in the model and then doing something else with, or not returning directly from the model.
Sorry, I didn't get it. So if you build a model with the data and you want to extract the data from the model, is what you mean?
No, if you actually, maybe I can ask you. Can I come and talk to you after?
Yeah. With the monster. Yes. Okay. Anything else? Okay, we have a 10-minute break, I guess.
Thank you.
Thanks very much.
We have 15 minutes break, so coffee, tea is there, and if you need the restroom, it's just that way on your right. Yeah, come back in 15 minutes. We have 2 more speakers here. Thank you.
Is this on? No? Now? Yeah. My name is Torgeir Hovden. I'm a co-founder of Signatur, and I'm going to take you through what I call a stream of more or less coherent thoughts.